Hello, everyone, and welcome to the Impractical Machinist podcast. My name is Patrick. You can find me on Instagram as @JobShopperTN.
I'm Cameron from Machining is Cool. If you listen to us on Apple Podcasts or Spotify, we would appreciate a 5-star rating.
I'm Bradley with Marvel Machining. Also, if you're on YouTube, be sure to give us a like and subscribe to the Practical Machinist YouTube channel.
On this episode, we're talking about machining new materials, properly cleaning your machines, and how to handle issues with a slow programmer, plus whatever else comes up along the way. So, guys, it's been a hot minute since we just had S3. We just had 4 guest episodes back to back.
Something like that.
I think we had Aaron, CNC repairman, then we had Tom from his car, Brad from Maple Lane, and then Sam with Monarch Manufacturing. So it's been a bit. So how you guys doing? How's everything going?
Kids are back in school for me, so now my youngest has got an earlier start time, so now I'm in the shop earlier, and I'm like, by the time 2-3 comes around, I'm like, damn, I'm done. I don't want to work anymore.
Get your
Hey, trust me, I feel that way too, Brad.
Well, usually I don't get out here till 8:39,
Yeah.
so it's 4, 5, 6 o'clock is all right, I'm good. But now I'm out here by 7:30, and it's
sounds terrible.
oh, dude, it's so early. I went and took a nap upstairs earlier this week.
Oh, that's actually pretty nice. I could stand to do that a day or two.
Absolutely.
You're at work.
I was just down here doing stuff. I'm like, you know what? Fuck this. I'm gonna go take a nap. I didn't even take my boots off. I just climbed into we got a day bed up there. I just climbed in and passed out.
We had a guy working for us one time that always napped in his car during lunch. Yeah,
Really?
he'd just eat something real fast and go out there and just conk out in his car.
Yeah,
You'd be
but
walking
one
by
was
and just
like-
see him in there with his head back and mouth wide open sleeping.
I might have done that times.
I remember a guy I used to work with. He was a wiry son of a gun, and he would scarf all his food down at morning break. We had 15 minutes at 9:30 or something. He'd scarf all his food down, his breakfast and then his lunch, and then he'd spend all lunch break in the break room sleeping, and hope that somebody woke him up. I don't ever remember setting an alarm. Fortunately, we were good to him, and we'd be like, "Hey, Jesse, get up."
Yeah.
But that was the funniest thing. Takes all kinds. Yeah, I mean, we've picked up some. I think almost the whole time that I've been working here, I've been talking about how slow we are, whatever. But it's picked up a little bit. We got some tooling orders in. There's some stuff happening with this company that probably can't talk about yet. But there's going to be some changes happening, and I'm hoping it's going to be a good thing. We'll see. But it should bring more work, and that's kind of the most important part. I don't want to get overloaded, but if we keep the tooling orders coming in and machine rebuilds too, then hey, we'll be in good shape.
Yeah.
I've actually been keeping both of the mills running quite a bit lately because a lot of the stuff we've been doing is longer run time. It might take, a couple hours to rough it out and finish it or something. So it's not too bad to, get the Haas running and the feeler running and just listen to them, hogging metal.
Oh yeah.
So that's been kind of nice. I'm going to be moving this computer back out to the shop before too long because I think this office will probably be repurposed soon, but also I'm hoping before too long I'll be able to finally start recording from home. I'm hoping next week, which will be, 2-3 weeks before this comes out, I should have power in my house. So hopefully maybe next episode or episode after I'll be in a very different place.
Nice.
Yeah, I've slowed down a little bit by my choice. I'd like to get up another building this year. I mean, kind of pushing it. I mean, it could fucking probably snow tomorrow. I mean, it's Minnesota, but I submitted for the permit, so hopefully I can start digging next week and get concrete poured and then find someone to come build it over the winter.
Yeah, nice, man.
We'll see.
What kind of building style are you going to go with?
I'm gonna do the same exact building I already have. So it'll have a full upstairs.
Mm.
My building right now, I got 2 dormers on the front and back,
Mm.
and then a patio off the front that looks over my whole property. But I took them off just it's gonna be storage upstairs, and then I did have to shorten it by 10 feet,
Mm.
so it's a little bit smaller.
Nice. So your property is going to be almost all building here shortly,
Yeah.
huh?
Yeah.
Cuts down on how
2
much you got to
buildings.
mow.
I haven't even mowed this year.
Really?
Yeah, I haven't even watered my grass this year.
Waters their grass.
You don't water it, you don't have to mow it.
I've noticed if you don't
Not
mow
around here.
I've noticed if you don't mow it, it doesn't grow as fast.
No, it
Like
doesn't.
Yeah.
last year, I hardly cut. I cut my grass maybe 6 times, 7 times, and it never really grew that fast at all. I don't know. It just didn't really get that tall. Didn't really need it. But now I got this zero turn, and I want to get out there and cut it all the time. Like
Yeah.
3 days later, it needs cut again. I swear it grows more the more you cut it. So maybe that's. I wish my
Mine.
bushes would do that. Those things are so overgrown.
Right?
I don't ever have time to get out there and screw with those. I want to rip them out. I got a tractor with a backhoe. I want to just rip the damn things out and just plant something
Yeah.
small there.
I mean, mine where I'm at, if I don't mow it, I have a hay field.
Yeah.
So, and I don't want that.
You just need to get a cow out there.
It's thinking about it.
Get a cow out there. You just let them eat grass. You don't got to do
Mhm.
anything. Then you kill them.
Yep. Yep. Exactly.
Yeah. I would like to do that. I mean, I've only got just over an acre, so it's not really in the cards for me, but maybe one day.
Yep.
I was going to
what
ask you
kind?
guys
Like,
where you're at on like form tapping versus cut tapping. Yeah, I know some people, they pretty much form tap everything they possibly can form tap.
I cut tap most stuff, but I've been doing a lot more form tapping
Yeah.
lately. But I mean, I'm not doing. I think the production jobs I've ran, I've form tapped.
Yeah. Yeah. I don't blame you there, especially depending on
Yeah.
the material. Like aluminum, I'll
Yep.
cut tap all day. I don't even
Yeah.
second guess it.
I mean, we barely have taps here. A matter of fact, I'm working out of a lot of taps that I have, but I have form tapped in the past, and it's amazing how much you can form tap nowadays, man. If you get the right grade. So, like I was saying, you can form tap a lot of different materials nowadays. I mean, they make taps that you can form tap tool steel, stainless steel.
Yeah.
I have ran as a test. I ran, I think, like 50 M3 holes with a form tap in like D2.
Wow.
And now,
Was it annealed?
oh yeah, it wasn't hardened or anything. No, but
Do you know how hard that is when it's annealed?
it's probably 20 Rockwell C or thereabouts. And I did use oil instead of coolant because I had no idea how good the coolant was in the machine. But now I understand that that's really not that good of a practice because that oil is going to end up in your coolant and make it gross.
Yeah. Yeah, we get that some with using Molly D.
Mhm.
We got some threaded rods that we make on the mill because there'll be like a 1032 thread, 1 3/4 long on a 3/16 rod. And so we made a die head that we can put just regular old thread dies in on the mill and use a collet closer. And so you throw a rod in there, close it, press go, it comes down and runs basically a tap cycle and cuts the 1032 thread, however deep you have it set. But yeah, we use Molly D for that. That seems to work best. Using it's a high speed steel die, and they're not crazy about coolant for whatever reason. They don't really like.
Yeah. Molly D's great.
It's 41.
It really is.
Distinct smell to
Yeah,
it too.
honestly, I kind of like the smell of Molly D.
Yeah.
I feel like I'm doing something.
Is Castro the only one that makes Molly
Yeah, as
D?
far as I know.
Mm.
I think that's like a proprietary thing for them.
Mhm.
I'm curious.
I'm sure other oil people have equivalent, but yeah, Molly D is good stuff.
Yeah. I wonder how they got that name.
Well, Molly D, it makes me wonder if there's like molybdenum in it or something.
Well, that would make sense. I don't even know how to repeat that word.
I don't
Sorry, is it too early for 4-syllable words?
No.
I don't even remember what you said. Malignum? What the fuck did you
molybdenum.
Maligma.
Oh God. Oh man. So,
It's not even called Molly anymore. It's now called Variocut. Oh, Variocut C Molly.
Hmm?
It does contain that word you said.
Yeah. You said it's not Molly D anymore?
Well, it says now called Variocut C Molly.
the woke mob got to it. They had to take it away.
I mean, I just bought some Molly D like a month ago, and the bottles look exactly the same, and it says Molly D.
Yeah.
So they must have just changed that if they did.
It's coming down in price a lot. I don't know the last time you bought some, Cam. How much was it when you bought it?
It's like, I don't remember. I remember the guy I was buying it from was like, hey, you may want to check MSC for that because it's definitely going to be cheaper than us. But so I bought it from MSC.
I remember it was because we at Galleons we used a lot of that stuff for manual tapping or whatever. Tapping stainless is great for that. And I remember buying some like during the height of COVID, and that stuff was like $100 something for a bottle.
For one bottle?
Yep.
Yeah,
Yeah, the little bottle.
yeah.
Yeah.
And that,
I remember the same thing because I buy it from Mars. I just usually email them because they don't have it on their site. And I think the first couple times I bought it was like 35.
Yeah.
So I shot her over an email. My neighbor wanted some. I was like, hey, can I get 2 bottles? And all of a sudden I got the invoice and I think it was 105 or something. I was like, what the fuck?
Yeah.
105
Well, right now it's
each.
$24 on the internet. So,
Yeah.
and that sounds about right with what I
better
paid. I bought a case of 12.
oh wow,
Oh, 1 bottle lasts me like 3 years.
Yeah. I mean,
yeah. You're not.
I
pretty much just buy a case of anything like that that's consumable that I know we're going to go through at some point. I just buy a case and it all goes in a cabinet, and we basically leave it in the box and cut the front and the top off the box. So that's like your storage for all that.
Yep.
So whenever
Man.
you're running out, you got 2 bottles left in that container or whatever. It's time to order. Same thing.
Patrick never even heard of a case.
I'm sitting here thinking, what about your cash flow, man? You spend all that money at one time, you're not going to have any money for anything else.
I know, man. It's rough out there. No,
All
no,
right.
the real killer is me scrapping parts because I don't know how to thread them.
Spend too much time on the mill.
I know.
You should use some of that expensive Molly D.
Huh?
Maybe you should have been using some of that expensive Molly
Yeah,
D.
then it really would have been good.
I don't think it would have. I mean, I don't think that would
That'll
have
make
helped
up
a
for any
whole
of your
lot.
problems.
No.
Just put some Molly D on it. Oh, you cut your finger off? Just put a little Molly D.
Oh,
Looks like
Golly.
a D2 annealed is 95 Rockwell B. I've been Googling it while we're talking.
yeah. I can't. I never think of Rockwell B. I don't.
I don't
ever-
even know. Like, it
Yeah.
doesn't work in my brain.
Yeah.
I have an idea
just-
of like, what 20 Rockwell C is,
Yeah.
that sort of thing, or like 50.
Right.
I know what I'm getting into, but you throw B at me, I'm like, beats me, man. Must be pretty damn soft if you're throwing B in there.
Yeah, that's kind of what I always think. I hardness tested some Delrin one time.
Really?
Yeah, at Galleons, we actually had a hardness tester. We bring it up to the diamond tip thing, and it presses it, and like it didn't even measure. It just put a big dent in the part, and just didn't really even do anything.
Yeah. Good old
That
Delrin.
was funny.
And I
Yeah,
hate the
love
way that
Delrin.
stuff machines or smells when you machine it. The machines,
Yeah,
I don't like
yeah.
the way it smells. It's not bad until
Machines
you get into like, I don't know. I was running Delrin for like a week and a half straight. It seemed like just nonstop, roughing and finishing. So you'd open the machine, it would like burn your nostrils.
Mm.
Is the just natural Delrin?
Plus, plastic in your coolant is generally not
Right.
great. It floats and kind of gets.
It's weird.
It's
Weird. Yeah. Luckily though, on that machine, that's the one that I made, like my own little filter situation, whatever you want to call it. I've got I basically bought just a big like storage container off Amazon. It was like 5 feet long and like a foot high. And then like where the spillways are coming out of the chip conveyor, it's like 2 just little chutes. And so I notched out for those chutes. And then I cut the whole bottom out of this thing, and I bought some stainless mesh. It's like 8/1000 openings, stainless mesh. Then riveted that and sealed that to that container. So now all the spillways come out right on that stainless mesh, and it catches majority of the stuff. I mean, Only
Nice.
really, really fine stuff actually makes it through. So I don't have any plastic in the tank after running that.
I bought one of them stainless mesh ones from a company, and it's great. I mean, I have to clean it out probably 3 times a day.
Right.
Where before it was like once a
Yeah.
week. But it catches
Yeah.
everything.
I'm gonna remake it. So I'm gonna actually laser cut and bend one out of stainless, and then I'm gonna go finer. Because 8,000, it's like that coolant still flows straight through it. And the last time we cleaned it, there was just, like, I don't know, like a silt, I guess you could call it, just like a sludge in the bottom of the tank. So I want to get finer to try to reduce some of that and maybe stretch our cleanings out a little further. Because none of our machines have easy to clean tanks. Only one does. That's our Johnford lathe, because it's kind of like a Haas mill where it's just like a tank sitting next to it. And I can just slide it out. It doesn't have wheels or anything, but it's got a handle at least. I can slide it out from underneath the conveyor and actually just pull the whole top off of it and suck the whole thing out, clean it out, put it back together. You probably have that done in an hour. Versus the other machines where you have to pull the conveyor sits down into the entire coolant tank across the whole front of the machine. And then so you got to disconnect hoses and whatever, and then get it off the jack screws and slide the whole thing out. And we never clean those tanks because they're such a pain. And there's not even like a good panel to pull off either. The only panel that you have that you could pull off like that is the panel where all the pumps are mounted. So you got your two, your 3-spindle and your flood coolant pumps, and then a centrifuge there, like a centrifugal filter for the 3-spindle coolant. So whenever you actually want to pull that off, it's, you got to take all the screws out, disconnect all the hoses and connectors, whatever. And then, I don't know, it's just a pain. So
that's how the YCMs were I ran. You damn near had to pull the whole tank out.
That's where we're at. You got to pull the tank out. If you wanted to truly clean the tank, you've got to pull the entire tank out from underneath the machine, take the entire conveyor out of the tank, which is not light. That's not something you're just going to pick up with 2 people. So pick the entire conveyor up out of the tank, and then pull all the sheet metal off, and then you can suck the whole tank out. And there's going to be crap in there because the filtration kind of sucks in those machines too. So yeah, I don't know. I need like a tank cleaning service. Put them on a subscription. Come by, and I'm sure they do.
Shop I worked at many years ago, they came out every year, but they like reclaimed it. They would boil everything out. They'd come in with this big ass machine and do both our machines. So they'd boil it out, evaporate the water, and then replenish all the machines. They'd be there for 2 days.
That's cool.
I don't know. It was hot as fuck when they came and did it though.
I mean,
you try to do it.
What is it, like a steam pressure washer or something?
I think
or just like a hot water pressure washer.
No,
because it had 3 tanks on the thing, so they pour it in and they'd cook it or whatever they did, and then they'd filter it and then filter it again, and then they'd pump out the coolant, and then they'd remix it all with water.
Oh, so you're saying they would get it back down to the coolant concentrate?
Yep.
What?
Yep.
I want to see how that works.
Yeah,
that's
they came out
neat.
once a year and did it. And that shop at that time, that place only had 4 machines.
See, I don't even care that much about saving that coolant. I mean, it's great to save coolant, don't get me wrong, because that stuff isn't cheap. But I care more about getting the tank clean than I do reclaiming that coolant.
Yeah. So they would clean the tanks too. So they would do everything. They would do 1 machine at a time. So then the machines were done running. So it took them 2 days to come do 4 machines.
Would they clean out the inside of the machine too?
I don't know.
That's what I want. I want a full cleaning service. Clean that entire machine top to bottom. Clean the tank out. Get all the dry that mist off the top of the machine.
How much did that cost back in 1972, Brad?
$200.
Yep. You buy a whole machine for that. That's how we're
that was the only company I've ever saw it be done at. Like nowhere else has ever done it. And there was a post on Facebook, somebody was talking about it too. So I kind of looked into it again, and it says a lot of bigger shops do it.
I mean, I'm sure after a certain point, it saves you money. Yeah.
Yeah.
Well, I'm sitting here thinking, here about 2 months ago, we cleaned out our feeler vertical mill and sanitized it and put new coolant in it. And it's just like what you guys were talking about. You got to pull the conveyor out, then pull the tank out, and all this. And our floor is terribly out of level, so that complicates things too.
Yeah, like the bottom of the tank will drag when you're trying to slide it.
Exactly.
Same.
And so it took the other 2 guys, off and on, probably 2 days to get this machine, cleaned out, the conveyor cleaned out as best I could, sanitized, and new coolant put in. And that's not all like active time, but if you sit back and think, okay, a 2-day project like that, what could the shop have been making instead?
100%. That's the way I look at it too.
Right.
And
Not that we had work at the time, but if we did,
yeah,
if we did, the machine would have just continued to smell like roadkill.
and also, who typically has all the stuff that they need to clean those tanks out on hand? You know what I mean?
Yeah.
And I don't know all the tricks, somebody that cleans those tanks all the time probably has a ton of tricks and like good tools and stuff to get all that stuff clean and scraped out.
Mhm.
I mean, we've got scrub brushes and like dustpans,
I bring my tank to the self-serve
Yeah.
car washing. Without
No, we we've just got a gravel parking lot. Well, part of it's paved, part of it's gravel. So the gravel section, which is right outside the shop, we'll bring the tanks out there with the forklift and then pretty much lift them up in the air, dangle them from straps, and I'll get out there and just pressure wash the whole inside of it so it can drain out while I'm pressure washing. And that works pretty good.
Yep.
I get the majority of it, and then the last little bit, just takes a little elbow grease. But to even get to that point, though, we've already done what I said earlier. You pulled everything out, disconnected everything, got the conveyor out of it. Because then you got to clean the conveyor, too, because it's been sitting in the coolant and just has kind of nastiness on it. So unless you don't want that back in the tank, you got to clean it, too. I'd much rather pay somebody, I don't know, I don't know what a normal price would be for that, but I'd pay $1,000 a machine to get that cleaned out.
Yeah.
And
Easily.
have it done in a day, and I don't have to worry about it. My guys can be making parts and making money while that's going on.
You might could even schedule it in a way where,
Well, that's
like, you don't even have any machine downtime in theory. If they would do it on like essentially like a second or a third shift, or on a weekend.
We'll take 2 days off and just let them clean it all.
Yeah.
You guys,
Kind of around the holidays, they'll take a day off early.
or just take 2 days off.
Yeah, because them cleaning guys don't deserve a holiday.
No.
Screw them.
Oh, a lot of shops close down, like over Christmas for like 2 weeks.
Yeah.
Well, at least in this area they do. So that week prior.
Yeah.
Must be nice.
I remember having a bunch of time off this past Christmas, but I think everything fell like during the week. So it was like, there's no point in coming in for the one day of the week you would come in for, or something like that.
I have found that cleaning my tanks regularly, just, having a coolant thing where I can suck it out, filter it out, pump it back in. And then once a year do the big clean out. It's not as
Yeah,
bad.
and that's what I would like to do, but even just to suck it out and fill it back is a pain on half the machines.
Really.
Yeah, because the only section where you can actually just like suck it out real quick and fill it back in is where there's a filter box between like the dirty side and the clean side, I guess you could call it. So you pull that filter box out, and then you could suck it out from that one individual spot. So you can't even get in there and like get chips out as you're sucking it out. So any chips that are in there aren't going to make it over to that filter box section because you've also got like a 1-inch lip all the way around it. So it's not like it's going to flow over to you. I don't know. It's dumb.
So I just buy a hose.
Whenever I look down and see that conveyor just nice and open running all day, and all the chips are just freely evacuating the machine, no matter how big they are, I'm not jealous.
Yeah, I can agree with that. Man, cleaning, that's one thing that's so funny. One of the silliest things to even think about, but it makes a big difference between machines and even just how they're configured is cleaning them out. Because let's face it, if you spend 15 minutes or 20 minutes a day cleaning out your machine, that adds up.
Yeah.
And if you can get that down to 5 minutes a day or 10 minutes a day or 10 minutes a week, it adds up. And like on our Haas, our VF4, the coolant pump's not the strongest, so this washdown nozzle doesn't shoot with a whole lot of pressure. And I've fussed about the auger on Instagram a lot because it'll get bound up with chips and back up and go in and back out. And it's it's wimpy.
Yeah.
But then you have the feeler mill, which has a much higher pressure coolant pump, so the spray gun is much stronger. It's got augers that push chips to the front of the machine and then a conveyor that takes them out. You can get a Haas like that, to be fair, but it is expensive.
Yeah. No,
Not that I want to spend anybody else's money, but to me, after seeing it, I think it's worth it.
yeah. We pretty much, I mean, if we spend time cleaning out machines, it's maybe 15 minutes a week.
That's pretty good.
We
yeah.
usually get in there with a broom and just kind of get what was left behind that didn't just naturally make its way out. Because pretty much all of our mills have, the 2 augers going towards the front of the machine that push the chip. It's slanted walls down to the augers, and then the 2 augers push it forward into the open chip conveyor, and it just drops on the chip conveyor and goes out of the machine. So, yeah, we'll get in there with a broom and just kind of knock all that rest of that stuff down to the augers and call it a day.
Next time I run that mill a lot, I need to see if I can actually run it with the chassis bath on all the time or part of the time. It has its own M code separate from the coolant to actually turn on the wash down bath. And I need to try to add that into a program sometime and see if it'll actually keep everything. Because if you don't run it, stuff still kind of builds up and you got to brush it out or wash it out to the augers.
Do you have a hard key?
But I wonder if it's.
Do you have a hard key for it? You just hit it while it's running?
No, it's just an M
I would
code.
definitely try that. And if it works, then you could add that to your post processor where it automatically adds it, or you could even make it an option where you can say like run wash down. Click yes.
Yeah. Or more accurately, I could have Possum add it to the post.
That's right. But
You can add it to your tool change too. Can you do an M code alias? That's what I have on my horizontal. In my tool change M code, I have my conveyors turn on every time.
Oh, that's cool.
So do they just how long do they stay on?
Forever.
Yeah.
They don't stop. I got to keep them running in the horizontal when that thing's going because it just goes up. So it just, I don't know if there's I have there is a timer in there, but I shut it off. Once in a while it shuts off, but as soon as that next tool comes out, it goes.
Okay.
But usually the conveyors just keep running.
Yeah, so ours have, you can change whatever the parameter is for turning the augers on. Our chip conveyors, they have a switch. You can switch it to automatic or programmed or manual. You got some options. We just leave it manual on and set the speed kind of slow and just let it run 24/7 while the machine's on. But then as far as the augers go in the machine, I got one machine I still need to do it on, but I changed the parameter to where anytime a program is running, those augers are running. So they're just constantly pushing any chips they may catch forward, drop them right in the conveyor.
Yep.
Conveyor's always running, taking it out. So I don't care. I'm not playing around with turning shit on and off. And
that's why I added it to my tool change M code, just so it's always on. But now that you say that, my conveyor does shut off. That's the only one that shuts off, but the screws coming out of the machine never do. I haven't looked into find another setting for that. But it'd be nice if because that one stops sometimes, and then I get a lot of buildup, and it's a little nasty to clean that thing out because I got to climb into the pallet pool.
Oh.
Yeah. So the tip that I was talking about is make sure that you have more distance than you think you probably need for the start of your thread cycle on a lathe. That's something I screwed up this past week. So I was basically worked out to be like 0.14 from the front of the part, and the thread starts at the beginning of the part. And that is a 1/8 pitch thread. And so that basically gave me, one thread to get it right for everything to couple up and give you a good thread. And then as I was walking the thread out, I don't know how it worked, why it happened, but it happened multiple times in a row and I couldn't figure out what was going on. But as soon as I would get the go gauge to go, the no-go would also go. So once I moved my start out to like 0.4 instead of 0.14, I don't know why I did that, but moved it out to 0.4, everything was perfect. Worked right. So pay attention to that.
See, that's the kind of stuff, I mean, truth be told, like, that's exactly what our impractical tip is for.
Yeah.
It's like little things like that. It screwed your part up, but you can keep somebody else from making that mistake.
Yeah, just don't do burning.
Should have thread milled it, Cam.
Thread mill everything. Yeah.
That's the bonus tip.
Bonus tip. I don't know if there's a general rule like, give it 2 threads start. Have you ever heard a rule like that?
No, but I usually, I guess not in turning because I don't do turning, but when I do thread mill, I usually give it more of a start.
Yeah.
I haven't ever really heard of a rule. I've always done, regardless of the pitch, I've always done at least, 100 on a fine thread, maybe 200 on a coarser thread.
Yeah.
I've never had to go as far as you did, but I mean, I haven't done a whole lot of super coarse threads like that before.
Yeah. Need to ask Luke from Crusader Machine, and I bet he'd have some good input there. I don't know. Comment if you know that.
Does it have to synchronize when it's coming in?
Yeah,
Could that
there's
be
a
why
constant
you-
RPM, so it was running at 500 RPM, and when it comes in, my threading bar is stopped, and then it starts the thread cycle. So the chuck's spinning the entire time, and so they have to couple together. I don't know the anatomy of how it works in the machine.
Yeah.
I mean, it's all ball screws and stuff, but
Well, if it's anything like all the lathes I've ran before, which are Haas, there's an encoder pulley. So there's a pulley on the spindle behind the drive, and there's a belt linked to something down below. And I've had problems on the SL20s and stuff that I had at my last job where that pulley started to get loose because it's just a set screw. There's nothing really all that great holding on. If it got loose and you got play in it, it'd get to where your threads would not sync up. So like from one pass to the next, they wouldn't line up. It doesn't sound like you're having that problem.
No, because it was consistent until I changed my start distance.
Mm-hmm.
Once I moved the start distance further out in front of the part, you could visually see the difference in the threads by looking at them. The starts looked different. I had some where there was like some crunchiness at the root of the thread. It was like it cut, maybe 10 thousandths off from the previous thread. But then by the time you get one full thread into the part, it was synced up. And you wouldn't see that anymore. It would be like a nice, smooth thread.
Yeah.
So, but yeah, I know what you're talking about with that encoder. Not that I know much about it, but I've seen it on like our Johnford lathe that has that. It's just right on top of the spindle.
Yep. Exactly. And honestly, you could probably have a similar problem on a mill with tapping.
Yeah.
I'm sure they sync up similar with the, spindle orientation and whatnot.
Yeah.
And you can see it in my machines. You can see it when it comes down. It'll do like kind of a little jolt before it goes.
Yeah. You can turn that off on Haas's at least, but that's only if you want to like maximize your cycle time, which for us generally doesn't matter. But that's what allows you to actually run your tap back in the hole if you need to.
Yeah. That's what I was about to ask, if you've ever reran the tap like that. I never do it. I'm always afraid. I know it's supposed to work.
Mm-hmm.
I'm always afraid to rerun a tap.
I've done it a couple times on like once in a while I get a print that has like a 3-place decimal on a tap, and it's like, fucking goddamn it. Like it doesn't matter, but I know it might get inspected.
Yeah.
So sometimes I'll run it, I'll leave it high, and then I'll measure it, and then I'll adjust my
3-place decimal on a tap depth.
It's always I assume most of the time it's a default setting when they go from cat to print, but I've been burned by it a couple times, so now I just do it. I see people complain about it too, and it's like, it's not that hard. Just
you do it once, measure where you're at, and then adjust your number. But or thread mill everything.
One of the things you gotta know your customer if they're gonna actually check that or not.
Right.
Like I got one customer, they do it all the time, but I'll blow it out by a half an inch, and they don't care.
Yeah, I've usually been in the thought process of as long as it can go as deep as they call, then you're good.
Yep.
Yeah. Same.
So if it says half inch deep and it goes 5/8 deep, then you have a half inch of engagement for your bolt. So
and generally they don't need that much. They might be using 3/8 or quarter thread. They just
Yeah.
Same thing with the drill depths. Go deeper if you need to, if you got the room.
Yeah, I'll cheat it down a little bit. Drill depths, I'll usually try to hit their tolerance, just because that's basically, if it calls for a 1-inch deep hole with a 3/4 inch deep thread, I'm gonna make it where you drop a gauge pin in and measure it that way. It's gonna be at 1 inch deep. And then sometimes when you have like a bottom tapped hole, I'll cheat it to the bottom of that tolerance. Like say it's plus or minus 20 on the depth, I'll go 1.015 deep. Then I can run my tap a little bit closer to the bottom. And
I'm curious, how close do you guys have your tap set up in cam to where, like, if you tell it, you're using this tap and you tap it so deep, it's going to come out within this range, like accounting for the taper on the tab?
I don't have anything set up in CAM for that. My taps are all just a big rectangle on the screen. I usually go based on what type of tap I'm using.
Yep.
It's like a plug profile, what 5 to 6 thread from the tip.
Okay.
Depending on the tip too, though, like sometimes with a pointed tip, it's even further. You can't just count on your touch-off point, but like bottoming taps, like a spiral point bottoming tap, I usually account for like 3 to 4 turns, and basically I'll go for 4 turns of the tap. So whatever your thread pitch is, 4 threads, plus your depth, and it's usually right there.
That works. That's one thing with Fusion where it's kind of funny to me. There's no that I could tell. It doesn't look like there's much definition for that on the tap.
No,
But with SolidCAM, you could actually tell it like the tip diameter, the length, angle, all that stuff. So before I came here, I actually had all my taps modeled for spiral point, were not exactly accurate because really they're a sharp cone and then a more gradual cone for the actual threading taper. But I basically have like 300,000 tip length. That means I need to go that much deeper to get full depth or whatever it might be.
That would be great, especially for simulation. Like you can be like, what I was talking about with trying to bottom tap. Say it's a 1-inch deep hole and 7/8 deep threads. I've ran the tip of the tap deeper than the shoulder of the drill was. It's a pointed hole or an angled hole at the bottom. I ran the tip of that tap down into that angled part of the hole so that I can meet that thread depth. But that was all just guesswork. But if I could, or some math, but also guesswork. If I could visualize that on a simulation, because I just trust the simulation most of the time. I'm like, oh, cleared right there. If it's the same in real life, it'll work.
I've done it a couple of times with spiral points where I'll just go tip to tip depth, so I'll just let it. Sometimes I'm like, oh shit, is it gonna just hit just right and break?
I mean, running a spiral point all the way to the bottom is pretty scary.
It is.
Because where are your chips going?
Right?
Yeah.
I don't do it too often, but there's been some odd sizes where I running the part and then it's like, oh shit, I didn't order this tap. And I'm just like, let's screw it, I'm gonna go for it.
Just go old school, man. Get you a 4-flute hand tab, half a turn at a time, back it up, go back in, squirt a little oil on it.
I do have a 4-flute hand tap in, I don't know what size it is, I have to look. I ordered it for something, but I ran it in my machine a few times.
Yeah.
It works.
Yeah. I guess as long as your chips don't build up too bad.
Yeah.
I don't know if I'd go like an inch deep with like a 3/8 straight tap, but
I think it's like a 7/16 something.
7/16 20 or whatever.
Something like that. And it's the part I got it for, it's an 1.25 inch deep tap.
Yeah.
So, but I drill it a lot deeper.
Yeah.
I think they actually call out a 2-inch drill depth and then an 1.25 inch threads.
Oh wow. Yeah, you got plenty of room there. You can just run anytime.
I think it's for some sort of heat thing where they thread it in and it's got the heat rod at the bottom of it.
Gotcha. I feel like 7/16 20 would be a pretty common thread for something like that, that weird fine pitch.
I had to neck a tap back last week. I had to do it the dumbest way possible. I had to put it in our old 1936 South Bend manual lathe, and then I had to hold a die grinder with a cutoff wheel up to it and grind back behind the threads because I needed like a 1/2 inch more thread depth than the tap would give me. And it was a weird tap. It didn't have any neck behind the threads. It just went from threads to shank.
Oh yeah.
So I had to do that. I tried to turn it, but that poor lathe just it couldn't do it.
Yeah.
That was fun.
Well, you guys want to take some of these questions that we got?
May as well.
I wanted to hit this one first from Carson_XLCH. Opinions on 2 different CAM softwares in a shop, for example, Gibbs and Fusion. And I think it depends on how much you rely on, or I guess how much 2 people would be working on the same part with different CAM softwares. If I'm machining my parts start to finish on my software and the other guy's doing it on his software and they don't really cross paths, not a big deal. And then whenever they do cross paths, there's just some challenges you have to overcome. Nothing crazy. But like say Sam, he'll run something on the lathe, so he's got a turned part with no holes, no other features machined into it yet. And then I'm going to machine it on the mill following the lathe operations. I basically have to model whatever he did on the lathe as my stock. That way, if you're doing any adaptive tool paths that are going to need to be stock aware, it actually knows what you have left. But that's been the main, I don't know if you want to call it issue, but just kind of a little hurdle. And if they have everything sketched up right in their software, then you can actually create a model pretty quickly in Gibbs. Well, I guess it depends on the scenario, but if it's that scenario I'm talking about where it's lathe on Gibbs essentially, and then all the millwork on Fusion, you can just revolve your sketch and create the model and then send the model over.
It's not too bad.
Yeah. Now the part where it can get difficult is say that person isn't there to modify their program, or you've got to run their programs from their software and you're not familiar with it, then you can definitely get hung up pretty quick like that, or maybe adjust some things you weren't supposed to adjust. Just not being used to that software can cause some issues whenever you try to actually modify things. So, or if I need to add one to, like I had this the other day, the whole program was pretty much right, but I needed to add one thing, like add an extra finish pass. And I had no idea what I was doing on Gibbs trying to add a finish pass on the lathe. So I just ended up, doing it on Fusion, but just reprogramming the whole thing. So
I think it's one of them. It depends. I mean, your shop is going to determine if you can get it done or not. I mean, I'd assume a larger shop that has a dedicated programmer and you got 15, 20, 30 machines, it'd be hard to have two, but that shop probably also has documentation. So if that job comes back, you probably know who programmed it. You can put it in there. So it always goes back to that guy. I worked at a couple shops that had different software and we never had issues with it. And, I mean, I could always hop on Mastercam or SurfCam and make adjustments to other programs, so it never bothered me. But if I was to hire somebody and they weren't a CamWorks user and they were good at Gibbs, Mastercam, whatever it is, I'd buy them the software they use so they can hit the floor running. They don't have to retrain. They don't have to do anything.
It is nice to have something same across the board. That way everybody knows how everything operates. And, as far as accessing programs and stuff like that, everything's the same all the time. Nothing really changes. But it's not like it's an impossible thing to have multiple CAM softwares, obviously. Like, we make plenty of parts that are made across 2 different softwares. We make really good money. It still works, It's not like it's a deal breaker or anything, but it can add frustration, especially whenever you don't know how to use that software. Like, I think Mastercam or whatever else you got, I don't know. Gibbs seems not super intuitive to just hop in there and create a new toolpath or do whatever. Somebody that knows what they're doing will probably hop in there in 1 second and be like, "Oh, this is how it works, right?" Just like that. But that's kind of the frustrating pain point for me, is just having to go back into their stuff. Changing feeds and speeds is no big deal because you just find RPM, feed rate, surface footage, whatever. Who cares there? But yeah, it's the modifications that gets me.
Yeah.
I can't say. I mean, when I started at my first job, they mainly use solid cam. They had a copy of Mastercam that the company did not realize was illegitimate. Some other programmer brought it in. I actually used it for a little bit because it's what I do from school, just barely, mind you. And that worked, but and once they figured out what was going on, they're like, "Okay, no, we can't have this." So I don't know. I'm kind of torn on it. To me, I think the benefit, I guess it depends on how the shop is ran. If you have machinists that program their own stuff and make their parts, it's like Brad says, get whatever software they are comfortable with.
Yeah.
Because it doesn't necessarily matter if you're going to hire them long term. Because you don't want to have 5 different softwares and be paying $50,000 a year for all these different software licenses. So there's got to be a limit somewhere. But then if it's a shop where you've got a programmer that programs for operators, like, my last job or whatever, you might want to have something more standard that way. Because if you have more experienced operators that can or should be able to tweak stuff, make little changes, repost their code, whatever, if the programmer's out, busy, whatever, it's a lot easier to teach somebody one thing than 2 ways to do it or 3 ways to do it.
Yeah.
So, I don't know.
I think a lot of shops have different cam for different types of machines.
Yeah,
now.
like EDM versus turning and
Yeah.
versus whatever.
That's fair. I mean, we did have OptiCam for a while when we had our EDM, because solid cams for our EDM module was apparently not very good. They told us that.
Yeah.
So that's fair. If you've got oddball stuff like a CMM or something like that,
CMM as well.
I could see that.
One tip I would give for anybody that's at a shop where you have multiple different cam softwares, document as much as you can for that job outside of that software. Like, for example, with Fusion, you've got a pretty good tool library there, and I can put all the information that you'll need for that tool. And so if you pull it back up, you can figure out what you need. But in GibbsCam, for example, there may be a standard tool library or a tool library built in there for you to use and pull your tools from. I don't know. I haven't found it. So you pretty much define your tools every time. And a lot of times it's just quick and easy. Like with turning, for example, you just define what insert you're using and call it a day. So then you don't know, what size boring bar they used or what threading bar they used, that sort of thing. What inserts they might have used, that worked in that certain material. So document as much as you can, have good setup sheets, tell you what stock size you need to have, like what it's programmed for, in your work coordinate, and exactly what tools you need in what positions, all that stuff. That'll really help mitigate a lot of the confusion or issues, like if that person's out or they're busy, you can't ask them right now or whatever. Maybe y'all don't have good communication between programmers and, the guys on the floor working. Then that'll pretty much get rid of the majority of that.
Yeah, if you're in a situation where you've got, you're programming 4 people, that goes a long way. Because I've run into that before. Like this one fellow that come to work with me before I left Galleons, and he's their lead programmer now. He came from a shop where, like, okay, he was the programmer. He also machined, so he'd program for himself, and he would also program for like a couple, 2-3 other guys, because they could. Usually, they'd get the simpler stuff. He'd do the more complex stuff for himself. And a lot of the communication they had was simple. It was just write it on the print, like, these are your tools, this is your pickup point, this is what your stock needs to be to go do it. And that worked for them, I think, based on just him and how close their shop was. He was right there in the shop with everybody. But then when he came there to Galleons, it's a little different. You've got more people that have wildly varying levels of experience, different machines, and they've got to come to an office to ask you something. So that's where I got him into, you make a Word document with, your tool lists, your setup notes, your part orientations for each operation, any notes about clamping depth and, all that kind of stuff. It is extra work. That, to be fair, it's an extra 10, 15 minutes on, a moderately complex part, but it can help reduce how much back and forth conversation and interruptions there's got to be. However, it also means that your operators can become reliant on that.
Yeah.
And if they have any single question about anything, instead of thinking for themselves, they're going to come ask you.
Yeah.
Because, and I'm not going to say this is the reason all the time, but partially because it falls on the programmer, not them.
Yeah.
So that's kind of the downside to but that's more of a management problem.
Yeah. I think it also depends on what you want your operators to turn into. If you just need them to set up and run machines and not really anything past that, then have good setup sheets. I mean, you can get pretty much anybody to run a machine if you got good enough setup sheets and good organization anyway.
The shop I just programmed I programmed for her, I don't know, like 8 to 12 machines. The setup sheets I created, I would give them a visual of the part and the vise, where the orientation was, side views, You got to use inch and a half parallels,
Mm-hmm.
how far it has to hang out of the vise. I gave them
Yeah.
everything, so it don't come out of
Exactly.
me.
That's what I try to do as well.
Yeah.
And I'll a lot, well, not a lot of the time, but really depends on what I got going on. But I'll just screenshot the setup on the screen, in Fusion, and then just put that on the setup sheet. And then I've got what work coordinate you're using, where your X and Y and Z zeros are going to be. I've got a whole section for setup notes, and then a whole section for operator notes. So in the setup notes, that's anything, like hardware. So what parallels, what jaws, that sort of thing. And then the operator notes are like, hey, cutter comp's turned on for tool 11. That's going to dial in, this 1/8 MPT bread mill, stuff like that. Or like, watch out for this, that sort of thing. Or like torque your vise to whatever. And then a whole tool list too with holders and stick outs and all that.
That's key. If you don't do anything else, if you're listening and you're a programmer for operators, if you don't do anything else, do that. That goes a long way.
It does. Man, it's the worst. Like when you get into setting up a job, like before I started programming, setting up other people's programs, they don't say anything about like stick out or anything, and you don't really know what tool's doing what. You might know with like a drill or a tap, obviously, but an end mill, for example, you're like, well, I don't really know how deep it's going to need to go or what we're even doing on this operation. So I'll just set it up and see what happens and then catch it before it crashes. So you have an end mill stuck out, an inch and a half, and then you realize it's going to go 1 5/8 deep. You're like, well, damn it. Now I got to stop, go pull the tool out further, retouch it off, and then start the whole thing over again.
Yeah. Yeah, that goes a long way. It really does.
Yeah.
We might as well go to this next question. How do you deal with the head programmer not running even close to manufacturer recommendations? We have rigid work holding, great tools, and a new Akuma. He gets mad if we make it fast. Open communication with your programmer. I never minded if somebody came in and asked me to change something. I did it. I mean, you're out there running it. I'd probably recommend documenting, run his program, if it takes 10 minutes and then you make your changes and at 6, document it and show somebody that can force a change.
Yeah, it does definitely depend on the structure of the shop, but that sounds like there's definitely an issue there with possibly with this programmer in question. If he's getting upset that people are making his programs faster, I can't understand that myself.
Well, it kind of depends on what is happening. Like if I'm making it faster and I'm like, yeah, we're machining these parts in 1/3 of the time, but then I'm blowing up end mills, every 3 parts, then I would get aggravated too. Like, stop messing with it, And if I think that what I'm doing is perfectly right and my way is the correct way, which, that's kind of, you have a lack of humility there, but then I'm going to get aggravated when you come to me and be like, yeah, I did this and I made it so much faster. But I don't know. Like if you're making it faster and the tools aren't breaking and you're still hitting the tolerances, then what's the problem? Are you getting mad because of your own ego?
Right.
Mad
And
that somebody else knew something better than you?
We don't know because we don't have the context, but that's kind of what it sounds like. I always went into programming with the mentality that, okay, the guy that I learned how to program from was very conservative with his cut parameters and everything. And he encouraged everybody to, okay, if you think you can run it faster, go for it.
Right.
Use your overrides, or if you want to play with it, what you can. I'll update cam. We'll try it again. And then I kind of, obviously I took that same mentality. I pushed a little harder than he would as far as aggressiveness. And there was plenty of times that I had to slow down a little bit.
Yep.
But I had the same thing. It's like, hey, listen, guys, now I would always say, if you think you can run it faster, go for it. And then I can update whatever you think needs updated. If some of the guys were competent enough that they could add like another spring pass, or they could, change their D numbers or whatever. And if they, if it was something that we thought might repeat, I'd be more than willing to update it. And because then I could learn something too. I'd be like, okay, maybe I can go a little bit harder on this or that, or, whatever it might be. And most programmers I've ever met or worked with think that way.
Yeah.
But to me, again, not knowing the context, that's something that is almost a managerial issue where if you, like Brad said, actually, if you can document, okay, we're making all these changes, and he's making a fuss when we do it, but we're running parts faster. It kind of
Not breaking jewels.
and not breaking tools,
Right.
correct. If there's no downside to speeding things up, then it's one of those things where maybe it is still better to have a safe base to work from, and then let your operators or machinists or whatever you want to call them, speed things up. That might be totally fine. But if it's because it certainly sounds like they have a good setup. I'm sitting here. I break tools occasionally because I push too hard here because, I'm having to fight, ER32 and TG100 chucks and, crap like that. So that's going to happen sometimes. But sounds like they're not in that situation. And who knows, this programmer might not be experienced in that scenario. I'm not. All I know is cheap tools, cheap tooling, and Haas machines.
Side lock holders.
Exactly. The good stuff.
Hey, they work.
Quick side note. We did finally get a couple of shrink fit holders. We got 1 3/8 and 1/2 inch. I haven't used the 3/8 yet, oddly enough, but I've used a 1/2 inch on a 1/2x2 5 flute. It rips. I love that holder. So, I'm going to keep playing with it some, and keep messing with it. But I definitely can vouch, off the bat that, it is a huge upgrade over certainly an ER collet or a TG100 collet. I might even begrudgingly say it might be better than a Weldon.
Mm,
Oh yeah, where's
that's debatable.
the hand clap thing? I'm all aware.
Oh, I've converted from Weldonism.
Shrink. New religion.
So to kind of
Get
get
from Dave and let him heat him up and crush him with the power hammer.
that'd be hilarious. He's done that with like retention knobs and stuff, hasn't he?
Yep.
That's cool. I guess to give this fella a more definitive answer. I mean, it really, I'm going to say from where I'm sitting, you kind of have to pick your battles and determine, is it worth it even you worrying about it?
Can he become a programmer?
Yeah.
I was going to say the same thing. Try to take
his job.
Yeah. Prove it and earn your way into his seat, or
keep adjusting those
alongside it.
speeds and feeds and adjust whatever you can to make it faster and figure out how to prove that what you're doing is making parts faster and also not killing your tools, and start learning how to program. Try to work your way
That's
in.
how I started.
You can learn how to program outside of work. You don't have to, rely on your company to train you how to program. If that's the mentality you have, you probably, aren't really going to end up being a programmer. I don't think a lot of companies are just handpicking guys from the shop floor and saying, "Hey, come be a programmer," even though we already have some.
Right.
You got to work your way in there.
That's how I started programming. The guy that was programming for mine, I mean, he was slow as shit. He was slow at getting the programs out, and he was doing the same thing. I was out there adjusting feeds and speeds. He didn't care, but I just started on Friday, started programming. He wasn't there on Friday, so I'd go use software and program my own shit.
Yeah.
Eventually, somebody noticed.
Yeah.
And then he ended up running a bridge cord, and I was programming and running the school.
Yeah.
Nice.
Same feeds and speeds though for him, huh?
Yeah.
Feeds and speeds didn't change. 1,015.
Yeah, that's a good point. It could be. Don't look at it as a problem. Look at it as an opportunity. And if you realize that it's not an opportunity, then just let him program like he's programming and go on with it.
Yeah, or find another shop.
So, yep. All right. So I think our last question. This one is interesting to me. I wonder if this fella might be an engineer, and I don't mean that in any derogatory way. What is your process for running a new material type? I mean, I'm not going to call it a process, but I basically just go to Google and look up machinability of this material, and usually it'll take me to the Practical Machinist forum, and I'll do some research and look at it and be like, okay, well, let's just start here.
Yeah.
If it's something really weird, I might ask, well, you guys, or the guy that I work with, or people I work with, or tool reps, and I just kind of wing it and go from there.
Yeah, I kind of wing it as well. I I'll look up. Well, I definitely don't wing it as much as Brad probably does. I look up. Typically, the first thing I look at is the hardness of the material. Check around online at some forums and stuff just to see, maybe it's a really abrasive material, even though it isn't that hard. Like stainless, for example. I'll look at different manufacturers' recommended feeds and speeds, so I can kind of compare. Like, all right, I know these materials on their little speeds and feeds chart. This is about where I would run for those, and I look at this new material I'm going to run, and say their SFM is 200-300 lower than what I would typically run for a material that I would think is similar to that. I'm like, all right, so I definitely need to slow things down. I don't want to have too high of an RPM, and then from there I'll just start playing with step overs and feeds and speeds as I machine. See what happens.
That's typically what I do too. Is I'll look at a tool's manufacturer, their recommended feeds and speeds, and then if I look at that end mill and I know where that's at, then I just base the rest of my stuff off of that.
Yeah. Sometimes I just straight up grab whatever their recommended feeds and speeds are, and I'll just hit the middle of all their ranges for SFM and feed per tooth and run it from there.
The worst is when you get one of them tool manufacturers that give you like a 200 to like 1500 SFM. It's like, thanks.
Yes.
I hate. Where do you want me to start? In the middle or the far left or right?
Seems like a lot of them. You get like a 200 or 300 SFM range. Yeah. I will say middle of the road or maybe on the lower side to start with.
Yeah. One thing that kind of gets I lose sight of is the safety aspect of it. Every material, in theory, if you have to be like an OSHA compliant shop, you should have a safety data sheet for material. So if you get a new alloy of material or something that you haven't used before, your shop should have a safety data sheet for it. It can help. Some people may not know, like titanium and magnesium are super flammable, or the chips are at least. Some materials might be, slightly toxic or something like that. So that's something that I should probably do more. Then again, if okay, it's a different steel alloy. It's still steel. I don't have to worry so much about that. But if you bring me a material that's some bunch of garbage I've never heard of, then I probably should look into the safety side of it more.
Yeah, I guess so.
Because you never know.
You guys ever had a machine start on fire from titanium?
No, I mean, I've never machined titanium, but it's funny because ever since I left Galleons, they've done a ton of it.
Really?
Yeah.
Company I worked at, we had one. They ran oil, and it just boom. I mean, and you could see it from across. I mean, it was so bright. It was crazy.
Yeah, I've seen some people have, they'll install a fire suppression system.
Yeah.
Whenever they're doing that sort of stuff. Or require you to have a fire extinguisher next to the machine.
Yeah, they had a fire extinguisher next. I mean, it only was 30 seconds, but it went up in flames fast.
How was the machine?
After it was cleaned out, you can't even tell.
It just burned up the titanium that was in there, and then that was it.
Yep. And I got a buddy that runs Swiss. He's had some start on fire too. He said, and they got the system in there. But by the time they're done cleaning it out and the company comes in and cleans it out, puts the new lines in, can't even tell it started on fire.
I think magnesium scares me more. I don't even know how you put magnesium out.
I think you got to have that, Class D fire extinguisher. But even then,
I don't know. Does it put magnesium out?
I always thought it did. I thought Class D was for metal, metal-based fires like titanium or magnesium.
But I want to say, well, I don't really know what I'm talking about here. I don't know. I just know magnesium is really bad, and it's like almost impossible to put out.
Yeah, I mean that's a good example of why
Yeah,
the-
that's Class D fire
There you go.
extinguisher
Pat Smart.
because it has a dry powder,
Man.
sodium chloride, graphite. Do not use water. Do not use CO2 extinguisher. Do not use foam. Dry sand or foundry flux.
Yeah.
Close the door and run to the parking lot.
I mean, I've been through so many safety seminars. Like in tech school, we had to go through that, and then several times at my last job, we had that kind of stuff. So it's kind of beating in my head. And that's why I bring that up. It's something you kind of forget. Some folks may not know that those materials are dangerous in that way. So, quick little funny story. The manual machinists at my last job, we're really good friends, and he sent me a video here a while back of they were slow, and so he was actually taking and facing off the ends of these titanium electrodes that they're making, and they're like 3.5-inch diameter by 3 feet long or so. So he had them on the horizontal boring mill. He was just facing each end, putting a center hole. But to deburr them, because he got a terrible burr, he took a die grinder to him, and he was amazed at like just the bright, pure white spark that he got off of it. Because when you grind titanium, that's what you get, and then obviously that's where you can get a fire.
Yeah.
So you got to be careful. But it was really neat to see that.
Yeah. Yeah. I guess as far as starting a new material goes, wing it. Is that the consensus?
Yeah, I mean,
Yeah.
I hate to answer his question like that because he asked, what is your process?
Yeah.
And
I guess
I can't say that I have a process for it.
I guess I mean
I remember the material that I had. It was something new. And I had thrown in the machine, put in the vise, and I had a tool in there. And I ended up just cutting part of the edge. I just turned it on like 2200 and I just hand fed it just to see how it cut was.
Yeah.
And I kind of played with it there, get a starting point. But I think I had to face aside. I don't remember why, but I was like, well, all right, well, this works. So I'm going to start here.
Yeah. No, I mean that's a good way of doing it too. If you can afford to mess around with it like that, just actually start cutting a little bit and see how it reacts to things. And you'll know.
Just do one profile cut.
Yeah. Look at your
Just-
chips.
Yeah.
If they're immediately turning blue as they're coming off, you might want to slow your RPM down a little bit. Or maybe take a heavier step over. I don't know.
Really, at the end of the day, if you get a new material and you know your tooling, you reach out to the vendor or your tooling vendor and say, hey, I got this material. Where do I start?
And
You'll
then they'll
get a
give you some
response pretty-
obnoxious fees and speeds that don't work.
Yeah.
Yeah, that's true too. It also depends on what your position is, because you might be getting the job after it's already been quoted and all that. But if you're at the head of it, it's probably better to figure that out ahead of time. If you
Yeah.
get an RFQ for a weird material, you should probably be asking those questions at that point.
Yeah, that's true.
And then that way you're prepared. Now, will that happen? Probably not, but you can at least try.
Yeah.
If you're in that position.
Yeah.
All right, that's all 3 of our questions. Appreciate everybody giving us those. That's all for this episode of the Impractical Machinist podcast. If you enjoyed this episode, be sure to subscribe on Spotify, Apple Podcasts, or the Practical Machinist YouTube channel so you never miss an episode.
Also, give us a like or a 5-star rating if you enjoyed this episode. Drop a comment down below what you learned from us or to share your own experience, and spread the word and let your fellow machinists know about us.
If you have any follow-up questions, you can DM us on Instagram, the Practical Machinist Forum, or on the Discord in our Instagram bios. Check out our Instagram as well. Job Shopper TN. Machining is cool. Marvel Machining.
Thanks for listening, and we'll see you next time. Keep those chips flying.
Brother.